Good afternoon and welcome to AP European History with Mr. Bobby. This afternoon we'll be talking about Chapter 18, Section 1, Toward a New Worldview. Specifically, Section 1 deals with the scientific revolution. As always, we'll be using the McKay, Hill, and Buckler text, 7th edition. The scientific revolution is argued in your text as being one of the foremost causes, if not the foremost cause in change in the worldview. Other events that we've previously talked about, including the Renaissance, seem to be more flashy or glamorous and get much more attention. But the scientific revolution really sets off a vast change for people. And it starts out ultimately with the upper class and the educated class, which is growing, but at a relatively slow rate. And it has a lot to overcome. Very key development in the evolution of Western society, not just in science, but in all aspects of life. Really, this whole chapter would not come about talking about the Enlightenment and enlightened absolutism without the scientific revolution and those people that are able to bridge the gap of scientific understanding from just a few very elite people to a more general populace. Western society stands out in the development of modern science. They take a lot more credit here than many other places in the world. And your text starts by giving us a baseline. And scientific thought in 1500 really was not too much different than it had been 2,000 years before. It was common sense, it was easy to understand, and it was all based on the ideas and theories of Aristotle. It was still considered a branch of theology, meaning it was connected to religion, and it explained the universe with a home for God that really suited Christians. And this was a key to the scientific revolution. Okay, there was a motionless fixed earth at the center of the universe, 10 transparent crystal spheres, and beyond the spheres was heaven. And this was a nice, neat, compact view for most common people that they could accept and they could acknowledge, and it would not break their religious ideals. Then we get to the Copernican hypothesis. Nicholas Copernicus was a Polish clergyman and an astronomer that felt there was something missing. And he felt that the work of Ptolemy was not substantial. He theorized that stars and planets revolved around the sun. And this is something that he wrote in On Revolutions of Heavenly Spheres. However, if you notice the date, 1543, and the date of his life, this was something that he was afraid to publish prior to that time. And it had some very dramatic findings. It put stars at rest. Okay, it revealed a universe of staggering and immense size, and it also theorized that the Earth was just another planet. And really, this was the most astonishing part for people, because the big question for them was, then where's heaven? Okay, before this point, with Aristotle's point of view, people still had a nice, neat way to kind of summarize a physical location almost of heaven. Protestants were more condemning than Catholics at this period of time, but both resisted, and both Luther and Calvin utterly dismissed Copernicus' work. From this point, scientific theory is very, very slow moving, and it's not until there's a new star that's detected in 1572 and then a new comet in 1577 that the tide is slowly starting to change, and it's getting more and more difficult for dissenters to fight the evidence that is being placed in front of them. The next part of this first section of the text goes through all of the scientists that really move us forward through the scientific revolution. And we have to start with Tycho Brahe. He's a Danish astronomer with a sophisticated observatory that he creates. He meticulously charts stars. The one downfall is that he is not familiar enough with mathematics. He still believes that planets revolve around the Earth, and really he provides a baseline. And it's not until his kind of assistant takes that and starts really doing scientific work with it. We cannot dismiss his findings and his observations, but they weren't really mathematically analyzed or proven until we get to Johannes Kepler, the German mathematician. And he scientifically analyzes Brahe's work and creates the laws of planetary motion. He deduces that the orbits are not circular, they're elliptical. Planets do not move at a uniform speed, and the time it takes to orbit the sun is in direct relation to the distance from the sun. And this is a very profound, this is really a key turning point in this scientific revolution. At around the same time, we have Galileo, Galileo Galilei, and he really develops experimental method, or this idea of a controlled process for experimentation. We so often take for granted, you've been studying science for a very, very long time, since elementary school, and at a very early age you're introduced to these ideas of an experimental method and a control test group and different things like that. On top of experimental method, the law of inertia and the idea that rest was not the natural state of objects, that they were constantly in motion unless being stopped. And also discovering 4 moons of Jupiter really crushes the crystal sphere theory. Then we get to Isaac Newton, Sir Isaac Newton, who's an English scholar and mathematician. He is a very eccentric professor, very motivated and driven by his work. For a long time he does work in alchemy, which is having to do with metals, and then he works with optics, and he finally settles on and goes later in his life through an 18-month stretch of just really hammering at physics. And he creates the law of universal gravitation. Every body in the universe attracts every other body in a precise mathematical relationship. And he unifies and he connects the universe through his theories of motion and mechanics. And this was really profound in the movement towards a more scientifically understood world. Causes and consequences. There are many other consequences than just some really, really brilliant men that lead us through the scientific revolution. And one of those that's not given very much credit is our medieval universities. And these universities really are at the foundation of an intellectual movement because this is a period of time around 1300 and even earlier that permanent universities with large student bodies start to exist, and we start to really, really blow up this idea or this field of academia and people studying and learning and researching. Philosophy developed as a secular practice from theology, and it's out of this philosophy that scientific study emerges. And this creates an outlet for the Newtons of the world. The Renaissance. The Renaissance cannot be dismissed. Finally takes a look at revisiting and recovering the finest works of the Greeks. Europeans were forced to resolve some of the ancient differences and conflicts in the research, and there were many patrons that not only endorsed art, but also endorsed scientific research. And there were economic motivations. Navigational problems on the high seas motivated countries to put money and research into finding better ways to chart courses, sea patterns, and mapping. And one of those that stands out is at Gresham College, and it's the Royal Society of London. The Royal Society of London is a group that does scientific research, studies scientific method, and they create an honored role in society for scientists to do their work. Other causes. The development of better ways to obtain knowledge, and this kind of goes hand in hand with the last bullet point, On the previous slide, better instruments and more accurate knowledge, things like the telescope, the barometer, thermometer, pendulum clock, microscope, and air pump. And then philosophers and writers. Francis Bacon derives the idea of empiricism, okay? Formal experimental research, an experimental method. He gains public and private support for science by means of a way to make nations powerful. And this is really how Bacon frames his argument to get people to buy in, is that this is something that is going to make our country, with rising nationalist sentiments, far more powerful than this country, and so on. René Descartes, okay, he's a French philosopher, and he really is contributing by discovering analytic geometry. He links algebra and geometry, and he creates something we call Cartesian dualism. Dualism is obviously two things, and this is the idea that not only is there matter or the physical part, but there's also the thinking part, the mind part, and this is where we get this mind over matter type of idea from. The role of religion. Religion is constantly at odds with this scientific revolution and scientists, and it will continue to be for quite a long period of time. Protestantism was more progressive than Catholicism. That's a mistake right there, than Catholicism. But it became more and more difficult for religious figures to impose their authority, okay, on scientific questions. Outcomes of the scientific revolution. It falls hand in hand with the new international scientific community, new knowledge and a concrete method for obtaining that knowledge. It shuns or goes away from tradition and establishment, and it had few consequences for the majority of people economically and socially, which is key. It has, once again, for an educated elite, more sophisticated consequences than it does for the general populace, most of which, who still, even though it would potentially or eventually make their lives better, disavowed it, okay, primarily on religious means.